Example 8, the top and bottom margins of a poster are each 5 centimeters. The side margins are 3 centimeters each. If the area of the printed material on the poster is fixed at 276 square centimeters, find the dimensions of the poster with the smallest area. So I think if I tap somewhere in here, there it is. Okay. So there's what's happening. We have a poster. This is printed material, and there's a margin around the poster. All right, so that's what they're setting up for us. All right, and it doesn't matter. They don't care about the actual poster itself. They want the maximum amount of area for the situation they want. So what's fixed is the side margins are 3 centimeters. And the top and bottom margins are 5 centimeters. Okay. The area of the printed material is fixed at 276. So this has to be 276 square centimeters, this inside rectangle. Okay? They don't care about the x and y dimensions as long as they get 276 square centimeters, but they want the smallest area possible for the whole poster. Okay? We need to have 276 square centimeters, but I don't want the poster to be any bigger than it has to be. Kind of what's happening here. If they limit the dimensions of the poster, they're limiting cost. It's a cost per paper. All right? I put the x and y on the inside. I could have just as well put x and y on the outside. Take your pick. By putting x and y on the inside poster, I know the outside dimension here is going to be x plus 6. The outside dimension here is going to be y plus 10. Because the outside dimension is the inside plus the margins, and the inside plus the margins. So we have the inside printed material, and then we have the entire poster. So those are two areas we're considering in this problem. Now, this right here has to do with the x and y dimensions I chose, right? So the area, x times y, should equal 276 square centimeters. For me personally, I like to set it up that way. Whatever they're fixing, I like that to be x and y because it makes for an easy equation. If I had gone the other route and made the bottom x and the side y, that now this is x minus 6, that's y minus 10. When I have x minus 6 times y minus 10 equals 276, all of a sudden I got a much more complicated equation to solve. So again, whatever they're fixing, let those dimensions be x and y, and then modify the other rectangle's dimensions. Yes, Renee?
Can you explain again how you got the x plus 6 and the y plus 10?
Okay, this is x from here to here, right? That's this dimension here. And this dimension here is x, but 3 and 3 more makes 6. And that's the same thing here. That's y from here to here. And this right here is still y, but you got a 5 and 5 makes plus 10. Okay? And again, the reason I'm making the outsides modified by margin instead of insides is because they fixed this at 276. If they said the poster has to be 276 square centimeters, now I'm going to call this x and this y, and that's x minus 6, that's y minus 10. So depending on what's fixed, I'm going to let x and y be based on that. All right, so y is equal to 276x to the negative first power, or you can go x equals 276y to the negative first power. It really doesn't matter in this case, they're both just as easy to do. Just as long as one equals the other, you're in good shape. Divide by x and then again create a negative power because we're doing calculus. Negative powers are easier than division. All right, so we want to minimize the area of the whole poster. So the area of the whole poster is x plus 6 times y plus 10, right? So A equals x plus 6 times y plus 10. I would probably at this point just go ahead and substitute 276 x to the negative first for that. If you wanted to FOIL it first and then substitute, you could. Take your pick when you want to do it. I'm going to do it there and just go ahead and FOIL it in that situation. So if I FOIL this, because I could do a product rule here to do a derivative, right? If I wanted to, but for me polynomial structure is easier than product rule, so I'm going to go ahead and do the FOIL. So first 276x negative first times x just makes 276, x to the 0. Outside x times 10 makes plus 10x. Inside 6 times 276, 1636 maybe? No, 1656. 276 times 6. 1656, second guess was right. Plus 1656, x negative first, and then last times last just makes plus 60. Right. So altogether, my area of the entire poster is going to be 10x plus 1656 x negative first plus 336. So again, the key to every optimization problem is going to be this right here. Can you create what you're trying to optimize, an equation based on one variable only? So everything within that process that I've given you is towards this end, to get you to what I want to optimize equals some equation involving one single variable. Looking at x and y, 0 to infinity again, right? X has to be bigger than 0. That's important here because x negative 1 is division by x, so we don't want to divide by 0, so obviously x can't equal 0, we can't have a poster, right? And obviously it's not going to equal infinity either, otherwise y is going to be really tiny. So we've seen posters, they aren't really long and thin. So, you know, kind of imagining the realities of what's going on here. So if I want to do a prime on this, I'm going to get 10 minus 1656 x negative second, and I'm going to set that equal to 0. Again, our critical numbers, endpoints, which no real endpoints there because 0 is not included. Undefined, the only place is undefined is 0, and 0 is not included. So equals 0 is the only place the critical numbers are going to occur. Most of the time that's the situation. You'll get an occasional one where an endpoint matters. In fact, we might see that tomorrow. But most of the time they don't matter. All right? Most of the time equals 0 is the critical number that's going to be what we're looking for. So just like before when we had negative powers involved, if I multiply by the positive version of that power to get rid of the fractions, I'm going to get 10x squared minus 1656 equals 0. That means that 10x squared equals 1656. Divide by 10, we get x squared equals 165.6. So x is going to be plus or minus the square root of that. Square root of 165.6 comes out to 12.87. Obviously, negative 12.87 doesn't make any sense in the context of this problem, right? So the positive one's the one we're looking for. So 12.87 was a critical number, so I'm going to go from 0 to 12.87. 12.87 to infinity. Verify that's actually a minimum. We're trying to minimize the area, right? My derivative is right here. So if I pick 1 and let's say 20. All right. If I do 1, I'm going to get 10 minus 1656, right? Negative. If I do 20, 1656 divided by 400 is 4 point something. 10 minus 4 point something is positive. You can obviously put a number in there also, but I mean you can actually enter your calculator to get the exact number, but all we care about is pluses and minuses. The graph goes down, then it goes up. We're hitting a minimum at 12.87, so that's the right value for x. All right. So finally, it wants the dimensions of the poster. So going back to what Chris asked in the last question, what do we know what to circle? Whatever they're asking us to find is what we're going to circle. So find the dimensions. So we're looking for x and y of the poster. All right. Now, what x represents is this right here. The dimensions of the poster, x plus 6 and y plus 10. So be careful of that. So I know x equals 12.87. And I know y is going to equal 276 divided by 12.87. So y is going to equal 21.45. Okay. That's the dimensions of the printed material. The dimensions of the poster are x plus 6 and y plus 10. So the answer to the question, I'm going to add 6 to this and I'm going to add 10 to that to get the actual answer to the question. So 18.87 centimeters by 31.45 centimeters. And 18.87 is the left and right dimension, 31.45 is the other one.